Many reactions don't proceed to form completely products, but instead come to a state where the concentration of reactants and products is stable, and we call this state dynamic equilibrium. The basic concept of dynamic equilibrium is that if we have a reaction of a chemical A turning into a chemical B, as the reaction proceeds, and we start maybe at a relatively high concentration of A, the concentration of A will drop. Instead of going to zero, we often see it sort of level out at maybe a relatively low concentration, but to have some quantity of A. What's happening is we have a bunch of A here, and some of it moves and forms a product B. My rate at which A is converting into B has slowed down a little bit because the concentration of A is a little lower. But chemical B, which may have started at zero, has now increased in concentration. And as it increases in concentration, B starts to convert back into A in a reversible reaction. And at some point, the rates of those forward and reverse reactions will balance out and come to be equal. And when that happens, we'll get a stable concentration of A and B as quickly as A is converted into B. And that rate was slowing down until the rate at which B converted into A, which is increasing as the concentration of B goes up. The rate of the forward reaction will slow down until B matches it, and then they'll be the same. And when that state happens, over here on the right side, where the concentrations become stable, we reach dynamic equilibrium. When we have dynamic equilibrium, the rates of the forward and reverse reactions are equal, but they are not equal to zero. They're still interconverting, and that becomes very important as we go forward and talk about things like Le Chatelier's principle. The concentrations of all the products and reactants are stable, but not necessarily the same. So at equilibrium, it is not necessarily true that the concentration of products equal the concentration of reactants. The reaction quotient is the same, but the concentrations may be different. So reaction quotient is the concentrations of the products over the concentrations of the reactants. And there's some exponents in this. This quantity Q is equal to a constant K at equilibrium. In the next video, we'll be talking about that equilibrium constant. And the other piece that's important here is that systems spontaneously move towards equilibrium. So if a system isn't at equilibrium, the rates of the reaction will perhaps slowly, perhaps quickly move it towards that equilibrium state.